Alright, what we got here is 4.3 part 2. We're going to talk about the difference of squares. The difference of cubes would work the exact same way. I'll write these on the bottom as well, but we're not going to give any particular homework problems for that one. That might just end up rolling into some of our other problems. So the difference of squares is a squared minus b squared. Anytime you see some formulation like this, therefore, you can do it as a plus b, a minus b. And so, actually, I'm going to modify one of our problems here on the bottom, and I want to put this as 81 x to the fourth minus, let's do 16. Make it a little more difficult. So, here's the thing, what I like to do. I like to go and say, hey, I've got x to the x squared minus 4. And you're like, hey, wait a minute, x squared. X squared's a perfect square. 4 is also a perfect square. So it must fit this mold, or this formula. And so I like to do something like this. Something squared minus something squared. Because really what's happening is I'm finding the a and finding the b from up here. So, what's being squared to get x squared? X. What's being squared to get 4? 2. And so now I know the a and the b. And so I could take those values and plug them into here. So this ends up being x plus 2 and x minus 2. And that's how easy they can be. So when I get down to the 81x to the fourth minus 16, I still can say, wait a minute, I do believe that is a perfect square minus a perfect square. What is being squared to get 81? And you should be like, hey, that's 9. What's being squared to get x to the fourth? X squared. What is squared to get 16? 4. So remember, that's your a and that's your b. So you get 9x squared minus 4 and 9x squared plus 4. Now I just did the order different than what I had up here. I put the minus first and then I added the second one, or did the addition second. It doesn't matter your order. A times b is b times a, or 2 times 2, or 2 times 3 is 3 times 2. It doesn't matter. Now, I'm hoping that you start to say, hey, wait a minute. This guy looks like it's done. I don't have a rule for the sum of squares. But wait a minute. Isn't 9x squared a perfect square? And 4 is a perfect square? Wait a minute. That means I can do this again. And this one doesn't actually change for 9x squared plus 4. But I can break this guy up. So you could say, hey, what's being squared plus what's being squared? Not plus, sorry, wow. Minus what's being squared. In the beginning, it's 9x squared. So isn't that a 3x? And 4 is a 2. So guess what? 3x plus 2, 3x minus 2. Like I said in the last video, it has to. If you can factor, you got to keep going. And that is the difference of squares. Now, I did hint at, I would tell you what the sum and difference of cubes are. Let me find a color here. So that one is a cubed minus b cubed. A minus b, and it's a squared plus ab plus b squared. Now, these actually have 2. That one is the difference of cubes. If you change that to a plus between, and a minus there, you will have the difference of cubes formula. So it works the exact same way that I wanted you to do here, is then break it to what's being squared minus what's being squared. Now you just say what's cubed minus what's cubed, so you can find a and b. Once you find a and b, you have a formula for it. So this is called the sum slash difference of cubes. The sum means add, difference means subtract. Now, what I want to do is I'm going to go a little bit out of order from the initial list and talk about grouping. Grouping, guys, is when you have 4 terms, 6 terms, 8 terms. It has to have an even amount of terms. Essentially, it's the greatest common factor in a way. I'm just taking a larger group of it. I put 3 steps on here. These 3 steps are the ones that I want you to follow so that you can do factor by grouping. Number 1, parentheses first, 2, and put parentheses around the first 2 and the last 2 terms. Last 2, I'm going to put terms. Terms. Now, what does that mean? It means when I go to my problem here, I see that I have 4 terms. I'm going to put a parentheses around the first 2 and the last 2. I highly suggest you notice that I put the positive inside this group. It's because the second group, according to step number 2, I need to factor each group. So when I get to the second group, I'm going to factor a positive number out or a negative number out. Therefore, I'm going to keep that sign with it. So in the first group, I think I should be able to take a 3a squared out of that first group. And if I do take that, I think we could work out that 12 divided by 3 is 4, and a cubed divided by a squared is a, and then the last group, take 3 and minus 3, a squareds are gone. Now, if you look at 4a minus 3, and you're probably thinking, I can't take anything. There's nothing in common. There's no variable a's in both of them, and 3 and 4 definitely don't jive. So, guess what? You still can take something. You can take a positive 1, because this group is the exact same thing that I had in the first group. And that is very important that I get the same thing, because if you look at step 3, it says you will have a common group, and it says take or factor that common term or group and then push together the leftovers. So 4a minus 3, and then I will push together 3a squared plus 1. Ta-da! You've just factored it. And I cannot factor those anymore. So let's try this one more time. So this time we have p's, that's okay. So put parentheses around the first 2, the last 2, and now we start to take. 2 and 5, I don't think I can take anything from a 2 and a 5, but I can take p squared. So if I take p squared out, I'll be left with 2p plus 5. Okay. I move to the second group, 6p and 15. Well, I can't take any p's out of that group, but it looks like I should be able to take, not a 6, oh, I could take a 3. I could take a positive 3. So I'm going to take a positive 3. That'll leave me with 2p plus 5. Hey, wait a minute, that's exactly the same thing right there. So I'm going to take both of those groups, combine them up, as in take them from them, leaving me with p squared plus 3. And you have now factored that one by grouping as well. So for your homework, I only have 4 of them. 4 factor by groupings. Make sure to use your parentheses, first 2, last 2, and factor each group and take the common group out, pushing the leftovers together. Have a great day.